Okay, here we are at Module C. And Module C really concentrates on street crossings at signalized intersections and really concentrates on APS. So let's begin. First of all, where are our students? Where do they live? About 33% of them live in cities, 37% of them live in suburbs, 28% in small towns, more non-metropolis type areas. 1% live in farm areas, much more rural. So in comparison to the general population, our students are somewhat overrepresented in cities, which would make sense because of their need for public transportation, and somewhat underrepresented in the suburbs. All right, street crossings. What are the steps that have to be taken? Pedestrian who's blind and crossing at a signalized intersection, they have to make sure that they have a good approach, a straight approach. They have to find the push button. Oftentimes that means moving away from the curb where they're going to make their crossing. It changes their alignment. They then have to go back to the curb, regain alignment, and then they have to make a crossing decision. And of course we know this, that listening is not as specific as seeing. You can't always identify the location of a sound. It's harder to localize. It's hard to know exactly what lane a car is in. A louder car can mask the sound of a quieter one that's maybe closer. Sometimes there aren't enough cars around to give enough information. And sound can be shadowed by different objects or buildings that block out the sound. Line of direction information is more general, not as specific as we would like it to be. So what are the tasks that are necessary for a blind person to cross? First of all, they have to locate the edge of the street. And that's not always easy because sometimes there's a curb and sometimes it's blended. Sometimes there are truncated dome tiles, sometimes there are not. A lot of variability. The person has to determine the geometry and the proper crossing alignment at the corner that they're located on. They have to determine the traffic control and when it's appropriate to make the crossing. And then while crossing, they have to maintain their alignment with the cars that are moving along their parallel street. So locating the edge of the street and finding the crosswalk may be very difficult. This is an example of something that's hard to find. It's blended, there are no truncated dome tiles. Somebody with low vision may be able to see the lines, but depending on where they're crossing, the lines may not even be visible. Here's an easier one. It has truncated dome tiles, and the lines are clearly visible. So what makes it easier? There's a clear approach path. Nothing in the way. The slope is directly ahead of the individual, not at a 45-degree angle. The crosswalk lines for a low vision person would be visible. That ramp is in the right position. Sometimes there's a color change or a sloping change at the street. And of course, even better would be and can be truncated dome tiles, detectable warning material at the base of the ramp that can be located with the cane. So of course we know that individuals have to determine their own alignment, making sure that it's parallel with the cars on the parallel street, so they're facing the right direction. And they have to project a line of travel across the street in their minds. And there are tactile clues sometimes on the walking surface. Sometimes something can be felt as they cross. And there's the incline and the decline as well. Here's an example of problems with alignment. Somebody gets to the corner, and the way the intersection is set up, it may be difficult to make a good crossing. May have to use recovery techniques. Much easier here because everything's in alignment. So what makes it easier? Number of things. A straight crosswalk path aligned with the parallel traffic and aligned with the approaching sidewalk on the other side. Does that happen? Yes, very often. Sometimes it doesn't. Having traffic in the near lane makes it easier to hear those cars. Crosswalk lines with good contrast makes it much easier for people with low vision. So we want to determine traffic control and an appropriate time to make that crossing. So the individual has to listen to traffic through one or more complete cycles. The individual can't get to a corner and just make a crossing. The person has to take time and listen. And the person has to start crossing with the surge of parallel traffic. And there are some issues that make it more difficult. Determining the pedestrian phase when the intersection has the following make it difficult. Intermittent or non-existent traffic, which is parallel to the traveler's path. We've seen that in some of our crossings already where we don't have a surge. There are crossings where there is no signalization at all, and we have to make crossings in gaps or with continually fast-moving traffic. And probably one of the most difficult things that we need to be working on with our students are split phases, or lots of right turn on red traffic. Another very difficult thing is finding the push button, because that push button gives the traveler extra time, but they're not always easy to find. In a situation like this, where's the push button? Even visually, it's hard to tell. It's over there. And think about the individual having to go press that push button and come back to the corner. What happens to their alignment? This is much easier. It's within close proximity to where the person's going to make the crossing. This is even better. It's right at the crossing. So what makes it easier? When the push button is at the edge of the sidewalk, when the push button is in line with a crosswalk line or less than 5 feet from the crosswalk line, which is the standard, although not always found. When it's located away from the parallel street so it's not blocking the sound. When it's near the top of the wheelchair ramp within 10 feet of the curb. And very, very importantly, when there is a locator tone. Because without a locator tone, very, very difficult to find it. And almost impossible. So the individual has to determine the correct time to cross. And for those with low vision, there's a visual pedestrian signal that they can see. They can look at the near side signal. And of course, the contrast, the glare can affect the visibility. But for many people, it's very usable. So, finding the pedestrian signal head across the street, in this case, may be hard to see. It's just below where my circle is. It's right about here. It's easier to see here when they're lower and when they're not as far away from the crosswalk. So what made it easier? The ped head is within the crosswalk lines. Lack of visual clutter and glare near the signal head. And it's not as high. It's between 7 and 10 feet high, not way, way above. So a person can also determine when to make the crossing without any sight at all by listening to the traffic, which all of us do under the blindfold. So if the traffic movement is predictable, it's easier. If there's a surge of cars starting and traveling parallel to the crosswalk, it's easier. Or if there's an accessible pedestrian signal to provide the walk indication. Now, that will have a tone which can be the same as the locator tone that someone hears as they're approaching, but it's with a rapid, repetitive rate. Or sometimes we'll find a cuckoo or a chirp bird call, or other tones. The cuckoo, generally speaking, is north-south. The chirp is east-west. And some of them are speech messages that will tell the name of the street, which is good for orientation. However, remember this, very, very important. The information provided by the APS must be used in combination with other skills and techniques. In other words, the start of the surge. The message, the repetitive raid, or the speech message really should be thought of as something similar to "get ready," and it's a surge that's the start. Now, the individual has to maintain alignment while crossing, and there are lots of techniques for this. Of course, we want to maintain our approach to the corner the way we have at all of the intersections, not letting where the cane stops affect where we stand. We want to listen to cars traveling on the parallel street and align ourselves with their direction. We also want to listen to cars stopped on the perpendicular street because we want to be between the cars stopped on the perpendicular street and the cars on the parallel street. Where there are visible or sometimes even tactile crosswalk lines, those are helpful. And it's even possible to align with the sound of the APS or the APS locator tone, which is on the opposite side of the street, because that tells us where it is that we're heading towards. Not always possible, but sometimes it is possible. Now, some crossings are much more difficult than others. This is a perfect example of why if someone aligned with perpendicular traffic, they would have a very bad crossing, but if they aligned with parallel traffic, they would have a better crossing, because the parallel traffic is a better indicator of which way a person must make their crossing. Of course, with a straight crossing such as this, a plus shape, it's much easier. So what made it easier? The traffic traveling straight through in the lane closest to the pedestrian, the straight crosswalk alignment, no turns in the middle of that crosswalk, and the cars stopped on the perpendicular street. Let's look at that again. Okay. So for people who are deafblind, there are certain strategies. Let's go back. And it depends upon the amount of vision and the amount of hearing that they have. If they can't see the pad head or the vehicles, they have to rely on whatever limited hearing they may have. Now, if they cannot hear the traffic reliably, they may have to seek assistance from other pedestrians. Now, one other thing that we should know about and we should teach is that many APS systems have vibrotactile information that can help an individual cross at familiar streets independently. It may be a spinning dial, and it may indicate when the signal has changed. Now let's talk a little bit about problems reported by pedestrians who have visual impairment and by their O&M specialists. There are actuation issues. The push buttons. A person might not know the push button is there. They can't find it. They can't tell which button is for which crossing. So we have to teach that. Their alignment is thrown off because they've had to go and push the button and then come back to the corner. Their button is too far away from the crossing. And then in crossing the arterials, the big busy streets, there may not be enough parallel traffic on the smaller side streets to help. And sometimes the actuation may be not as predictable as we would like. So it's hard to determine or discern the walk phase when the following has occurred. If there's an exclusive pedestrian phasing approach, if there's split phasing, if there's a leading pedestrian interval phasing, if the surge is masked by right turn on red vehicles, if the environment's too noisy, if there aren't enough traffic surges cars, if the surge is too far away, if there's a left turning phase, and if there's during late night operations, a lot of this may change. All of these things cause problems. There are also geometric issues. Very wide streets, when that happens, veering is much more likely. The parallel surge across that very wide street may be too far away. Sometimes there are offset angles, make veering a problem. The curb ramps can make problems. Sometimes if they're set in a diagonal or 45-degree alignment, makes it difficult. Sometimes it's hard to even detect that they're there. And then roundabouts, a special situation that we will talk about at another time. Very, very difficult. There are other geometric issues as well. The T-shaped intersections. Crossing at the top may cause some problems because of cars turning right. Cars aren't going through, they're all turning if you're crossing towards the top of the T. There may be low volumes on the stem, and they can't tell when to make the crossing. Those are some of the issues. So the APS, where they exist, is a wonderful solution for pedestrians who are blind and visually impaired. The audible vibrotactile indication of the walk tone is very, very helpful. Even though it doesn't tell the person that it's safe to walk, it's telling them get ready. The locator tone tells them where the button is. The APS might even help with alignment, as I've mentioned. They may not hesitate as long to make their crossing because they are getting ready to make the crossing. Those that are audible messages, voice messages, may help with orientation by giving the street name, sometimes the shape of the intersection, or even the presence of an island being there. So there's increased independence at familiar intersections also for deaf-blind persons with these APS devices. Now, we also need to work with many travel professionals in our own profession. The MUTCD has basically said that O&M specialists might provide advice on installation of APS, and that's something that we need to cultivate. Local organizations who provide support to consumers with visual impairment can help us and can be important advocates for us. Teamwork is really what's best. So we all have to work together, O&M specialists, guide dog instructors, consumers. When there's new construction, we have to be concerned about whether an APS should be put in. We have to think about retrofits when intersections are being restored, putting in an APS. We can think about what kind of APS would be best at a particular corner. We can be involved in some of those decisions that are made, and then publicizing that they are in when they're in to our consumers. So all of these things are very important. We'll all have a role in these. It's important that we understand exactly how to become involved, and we take the steps that are necessary.